Good evening, student. It's the last lecture of module number 4. In the last lecture, we will discuss the procedure to find the orthogonal trajectory when the equation of the curve is in polar form. Now we discuss with some example of this procedure in this lecture, and that should be the last lecture of Module 4 BSCCSE201 or BSCECE201 Ordinary Differential Equation. So it's the example, find the orthogonal trajectory of the cardioid r equals to a1 minus of cos theta. If you put the equation of this curve r equals to a1 minus cos theta, the design of the curve is exactly like heart, exactly like your heart. For that reason it is called the cardioid. The name of the curve is cardioid. So in the last lecture we have already mentioned that when a family of curve is given in the polar form and you have to find the orthogonal trajectory of the given curve, in that case first we find the differential equation of the curve. Next we replace d theta by minus r square d theta dr to find the differential equation of the orthogonal trajectory. After finding the differential equation of the orthogonal trajectory, then you solve this differential equation to get the required equation of the orthogonal trajectory. Here you use the same procedure. The given curve is r equals to a into 1 minus of cos theta, where a is your parameter, so you have to eliminate a from this equation. Exactly for that reason, here the number of parameter is 1, so you have to differentiate with respect to theta, because here theta is the dependent variable and r is the independent variable. Exactly for that reason, here we differentiate this equation with respect to theta. The result becomes dr d theta. A is constant, so the result becomes 0, and minus a cos theta. When you differentiate minus a cos theta, it's become plus a sin theta. So the value of a is dr d theta by sin theta. If you put this value of a here, you can find the differential equation of the given curve. Exactly here we write the procedure eliminating a from 1 and 2. We obtain. The question is, how can I obtain this result? Okay. So this one dr d theta, here we dr d theta and divide by r, it's become 1 by r, so the result become a cos theta by a sin theta by a minus cos theta. A should be cancelled out from numerator and denominator, and sin theta is expanded by 2, sin theta by 2, cos theta by 2, and 1 minus cos theta is the formula of partial multiple angle, probably 2 sin square theta by 2. So sin theta should be cancelled, sin theta by 2 should be cancelled out from numerator and denominator. In that case, denominator consists cos theta by 2 and numerator consists sin theta by 2. So the result becomes cot theta by 2, which is the differential equation of the given family of the cardioid. So when you find the differential equation of the orthogonal trajectory, you have to replace dr d theta by minus r square d theta. If you use your IQ, in that case you can also recognize this portion 1 by r dr d theta should replace by r minus r d theta dr. Exactly this. Okay, replacing r dr d theta by minus r square d theta dr, that is same as 1 by r dr d theta is replaced by minus r d theta dr. Okay, so use your brain, you can easily recognize the result. Okay, so exactly for that reason here 1 by r dr d theta is replaced by minus r d theta dr. Here is this. Okay, exactly for this one is cot theta by 2, or when we take its dr by r plus tan theta by 2 d theta, integrating both side, we have this one dr by r is this, and when you integrate this one the result becomes this. Integration is log r 2 log cos theta by 2 log c. If you eliminate this log, the result should be this one r cos square r c cos square theta, because this 2 is should be the power of cos theta by 2, so it's become cos square theta by 2 c cos square theta by 2, r equals to c cos square theta by 2, and that is your required result. And if we use half into 2 cos square theta, that is 1 plus cos theta, and c by 2 is replaced by a dash, then it's become r equals to a dash cos a dash into 1 plus of cos theta, which is the required orthogonal trajectory. It's the last example for module 4, and that I've already mentioned that it should be your last class for module 4. Find the orthogonal trajectory of the family of curve r to the power n equals to a sine n theta. Here we mention a special technique for you. If in any curve, r power is more than 1, in that case r power is not 1, in that case you just take log both side with the base, and after then differentiate both side with respect to theta. That should be the best procedure to find the orthogonal trajectory of a polar system curve. Okay, so here the power is n, which is not 1. If it is 1, then you start your differentiation with respect to theta. If it is not 1, in that case that should be the best procedure. First we take the log. When you take the log, the result becomes n log r equals to log a plus log sine n theta. Next we differentiate with respect to theta, because you have to eliminate your arbitrary parameter term. This one is a. So when you differentiate after taking log, the parameters should eliminate automatically, and you directly find the differential equation of the given family of curve. Exactly for that reason here, if we differentiate this one, it becomes n into 1 by r dr d theta. Log a should be 0, and this should be 1 by sine n theta. So differentiation of sine n theta is cos n theta, and after this differentiation of n theta is n into 1. Exactly for that reason here we use the result in cos n theta sin n theta, and this one is your required differential equation of the given family of curve. So when we want to find the differential equation of the orthogonal trajectory, we have already mentioned in the previous lecture, if we replace 1 by r dr d theta by minus r d theta dr, you can easily find the differential equation of the orthogonal trajectory. Here we replace dr d theta by minus r square d theta dr. So this become your the differential equation of the orthogonal trajectory. Okay, clear? After solving this differential equation, we get this result, which is the required solution of the orthogonal trajectory, which is here we use some technique to represent the curve in very fine way, or looking very nice. Exactly for that reason here it is log r sin n theta by cos n theta, that is 1 by n sin n theta equals to c. That result here we give a mistake. This one should be log cos n theta. Okay, so taking the logarithm, it's become log r to the power n, log r to the power n, and this becomes nc, and nc, if we represent nc by log b, so the ultimate result becomes r to the power n b cos n theta, which is the required orthogonal trajectory, So that's all for the last lecture of module 4. Happy learning, and stay in your home and save your life. Stay in your home. Thank you for listening.